Welcome to Nick Does Maths. Now, the eagle-eyed of you that also follow us on TikTok, do go check us out on TikTok, will recognize this. We may be getting flashbacks at this point of these particular set of equations. This has just been my jam for a while here. So we're back to the parametric equations x equals theta minus sine theta, y equals 1 minus cos theta, and we're keeping theta between 0 and 2 pi. This is what the curve looks like. If you want to know why the curve looks like, why this is actually completely vertical, go check out the TikTok videos. There's a whole series of them exploring what this is doing. It's kind of cool. But what we're going to do now, and this is why this takes a little bit longer, is we're going to find the arc length. So I want the length. How long is this chunk of curve? The answer may surprise you. Okay, so we do need to know what is the formula for arc length. All right, now a little bit of arc length, a little bit of arc length, a little bit of curve is, if you focus in on a bit of curve, is square root of dx squared plus dy squared, all right? We're not going to go in, but if you've got some curve, right, and you want to know a little bit of arc length, you can approximate it because everything is really small. We approximate it with a triangle, and just Pythagoras says that a little bit of arc length is dx squared plus dy squared. Okay, now let's just go with that. So we need to integrate the square root. We're going to add up all bunch of these. Now what we're going to do is, much like always, I'm going to times by d theta and divide by d theta. But the way I'm going to do that is I'm going to divide by d theta squared. So what we need is the integral. And if you plug that back in, I end up with dx by d theta squared plus dy by d theta squared d theta. So this will give me my arc length. Technically, there's some brackets in there. Okay, this will give me my length, my arc length. So, what is dx d theta? Now, we are used to this. I mean, if you're me, you've done this quite a while. 0 to 2 pi square root of dx by theta is 1 minus cos theta all squared. Oh, going to need a little bit more space in here. And dy d theta is just sine theta. So that's sine squared theta. Let's expand this out. So that's 1 minus 2 cos theta plus cos squared theta plus sine squared theta. So what this comes in as is the integral between 0 and 2 pi of the square root of 1 minus, no, because cos squared plus sine squared is 1. So 1 plus 1 is 2. This is the integral that I need to deal with, the integral of 2 minus 2 cos theta. Easy? Let's find out. Right, I'm going to put this back at the top of the board. And in fact, I'm going to pull out a root 2. Don't hate me. So, we need to deal with this integral. Now, I'm not entirely sure what I'm going to do, but tell you what, let's just start with u equals cos theta and see where it takes us. Because we might have to change things up a little bit, and I'll try and explain to you why. U equals cos theta. Well, du d theta becomes minus sine theta d theta, so that's okay, that's a thing. But sine theta is square root of 1 minus cos squared theta. Well, okay, it isn't, it's plus or minus, right? It's plus or minus. Okay, so because of that minus, that becomes a minus plus, and it's very important for us. Well, actually, let's just keep it like there. Let's keep it like that for now. We'll see what goes on. There's only so many d thetas I need, right? So we end up with the integral, root 2, the integral from Now this is a problem for me already. Because when theta is 0, u is 1. And when theta is 2 pi, u is 1. So that's a problem. Now the other problem is here. So theta is between 0 and 2 pi, right? Well, is sine theta square root of 1 minus cos squared theta, or is it minus square root of 1 minus cos squared theta? And in fact, it turns out, when you check out their graphs, this part is true for theta between 0 and pi, and this one here is true for theta between 0 and pi and 2 pi. So what I don't want to do, first of all, I've got these two limits that are absolutely horrific for me. And also, I'm going to have to split up my integral anyway, because this is a minus all of that, or it's a plus all of that, depending between 0 and pi, right? Because this is true between 0 and pi, and between pi and 2 pi, I pick up an extra minus. So what we are going to do instead, it is easy to see that this thing is symmetrical. So what we're going to do is instead, we're going to go from 0 to pi instead. So what we are going to do is going to double it. We can go from 0 to pi and double it. We'll find the length from 0 to pi and double it. Okay, because now 0 to pi sine theta is positive square root of 1 minus cos squared. If you're not sure where that minus comes from, just go have a look at the graphs of sine and cos and think to yourself, well, between pi and 2 pi, cos is of a certain value. What about sine? And you'll see what goes on. So, yada, 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 yada. So now, let's have a look, because I think my limits do some nicer things. So when u is 0, when theta is 0, u is 1. And when theta is pi, u is minus 1. These are upside down, but the more eagle-eyed of you will realize that that is there. Now, why have I done this, actually? Probably should have explained why I did that. Why have I done that? Well, because that is minus square root of 1 minus u squared d theta. So I can get d theta in terms of du. So I'm going from 1 to minus 1, which is horrible, but there we go. We get a square root of 1 minus u, and then we get a minus du over square root of 1 minus u squared. Okay. Now, one thing we can do, because we as well good at maths now, we know that that negative can be used to flip those the correct way around. We've got a square root of 1 minus u. Now what we are also going to do is we're going to factorize the 1 minus u squared, because 1 minus u squared is 1 minus u, 1 plus u. And now we are in Happyville, because those have gone away. So we end up having to integrate 1 over square root of 1 plus u. And that gives me, that is a 2 root 2 is still there, because I think that becomes 2 square root of 1 plus u once you integrate it. And what happens to this, that is 2 root 2 times, put in the 1, that's 2 root 2, and put in the minus 1, you get 0. 2 root 2 times 2 root 2 is 8. So this thing here, like I've been playing with this like for hours at this point. This length there is 8 units long. Come on. Come on. Now, that might give me a clue as to what this shape is, of course. Because if that's there, we could take this as a radius of pi. Oh, is it almost? No, it's not a circle, is it? Because that's length pi, and that length there is 2, so it's not a circle. Could it be an ellipse? I don't know, but definitely that length there, across all that being 8, makes me really happy. Okay, please do go check out the other series. There's about 4 or 5 different videos talking about this set of equations over on TikTok. Do go check it out. In the meantime, I am Nick. I've been doing some maths for your viewing pleasure, for a given value of viewing pleasure. Don't forget to subscribe, drop a comment. Was there a quicker way to do this integral? Do you have another substitution that might make this integral even cooler? Do let me know. hit the notification so you know when more maths is being vomited your way, and I will see you then. So in the meantime, toodles.